All right, in this explainer, we are diving into the blueprint for quality. We're going to break down a really foundational process for building software that actually works, the software testing lifecycle. But let's start with a question that I think we've all asked ourselves at some point. You know that feeling, right? You download a shiny new app, it looks incredible, and then boom, it crashes. Why does even the best looking software still have bugs? Well, a lot of the time the answer comes down to how it was tested. And here's the kicker. Getting that testing wrong isn't just annoying. It's incredibly expensive. It costs 5 to 10 times more to fix a bug after a product is out in the wild. And that's a massive drain on money, on time, and, of course, on a company's reputation. So how do we avoid that expensive mess? Well, the answer is having a structured, methodical plan for quality. So let's introduce the star of our show, the software testing lifecycle, or as we'll call it, the STLC. Think of the STLC as the official rulebook for testing. It's not just random clicking. It's a specific sequence of structured steps that makes sure nothing gets left to chance. It turns testing from a chaotic art into a systematic science. Now, it's super easy to get this mixed up with its bigger cousin, the software development lifecycle, or SDLC. So here's the simple difference. If the SDLC is the entire blueprint for building a house from the ground up, the STLC is the super detailed inspection plan for the foundation, the plumbing, and the electrical. It's the dedicated quality check inside that bigger project. The STLC is basically a journey, and it has 6 distinct phases. So let's walk through it together, starting from the initial plan all the way to the final report card. And here's our roadmap. We kick things off by analyzing what we even need to test. Then we move into planning, actually writing the tests, setting up the environment to run them, executing them, and finally, closing the whole cycle out. See how each phase just logically flows right into the next? It creates a really complete loop. What's really neat is that every single phase has a crystal clear goal and a tangible output, something we call a deliverable. So for example, in requirement analysis, the whole point is to figure out what's testable, the deliverable, or requirement traceability matrix. Fast forward to test execution, the goal there is to find bugs, and the deliverable is a stack of defect reports. This structure makes sure every single step has a clear purpose and a real outcome. Okay, with all these moving parts, you might be wondering, how does this not just turn into total chaos? Well, the STLC has a built-in mechanism to enforce discipline, and it's called quality gates. Let's see how this works. To keep everything on track, each phase has these quality gates. You can just think of them like checkpoints. Entry criteria are the things on your checklist that you absolutely need before you can even start a phase. And exit criteria are the things you have to complete before you're allowed to finish and move on. It's basically permission to start and permission to finish. Let's make this real. For instance, you literally can't start the test planning phase until the requirements analysis is 100% complete. That's your entry criteria. And you can't say you're done with test execution until every single test case has been run and all the show-stopping bugs have been squashed. That's your exit criteria. These gates are what prevent teams from just rushing ahead with half-baked work. Now, you might be thinking, this all sounds pretty rigid, a little old school. But what's cool about the STLC is how surprisingly adaptable it is. Let's see how it fits into the super fast-paced world of modern development, like Agile. So in the Agile world, the STLC doesn't just disappear. It gets put on fast forward. The phases start to overlap and run in these short, continuous cycles that line up with development sprints. And this means testers and developers aren't in separate rooms anymore. They're working side by side, collaborating constantly. And the rocket fuel for this speed? It's automation. In modern development, teams have these things called CI/CD pipelines that are constantly pushing out new code. This means the whole test execution phase can be fully automated. So every time a developer hits save on a piece of code, a whole battery of tests kicks off automatically. The team gets instant feedback. It's a game changer. Okay, so after all this talk about phases and gates and automation, what's the bottom line? Why go through all this trouble? Well, it all comes down to delivering real, measurable value. In other words, better software. And you know, the numbers really don't lie. When companies properly invest in test automation as part of their STLC, a whopping 79% are satisfied with the return on that investment. They're definitely seeing the benefits. And get this, that return on investment isn't something you have to wait years for. Over half of companies that go down this path see a positive return in the very first year. So here's the crucial point. A mature, well-run STLC has a direct, really positive impact. We're talking about a 40% reduction in bugs that customers find out in the wild, a 30% drop in defects leaking from one stage to the next, and getting products signed off and out the door 20% faster. Those are some serious numbers. So what are the big takeaways here? If you want to get this right, here are the pitfalls to avoid. First, don't wait to start testing. We saw just how crazy expensive those late-stage bugs are. Second, get your requirements crystal clear from day one or you'll just waste time. Third, you gotta embrace automation to keep up. And finally, none of this works if your teams aren't talking to each other. Communication is everything. And that really brings us to the core truth here. No matter how fast development gets, no matter how fancy the tools become, the STLC remains the fundamental cornerstone of quality assurance. It's the structure and discipline you need to build software that people can actually depend on. Which leaves us with one final big thought to chew on. In today's world of nonstop updates and continuous delivery, where software is never really done, what does our standard for quality truly mean anymore?